Hello student, good morning. I am Dr.A.K. Today I am going to discuss significance of uncertainty principle. One of the important implication of the Heisenberg uncertainty principle is that it rules out existence of definite path or trajectories of electron and other similar particles. The trajectory of an electron or of any object, the trajectory of an object is determined by its location and velocity at various moments. If we know where a body is at a particular instant, and if we also know its velocity and the forces acting on it at that instant, we can tell where the body would be sometimes later. We therefore conclude that the position of an object and its velocity fix the trajectory. Means velocity and positions are essential to fix the trajectory. Since for a subatomic object such as an electron, it is not possible simultaneously to determine the position and velocity at any given instant to an arbitrary degree of precision. It is not possible to talk of the trajectory of an electron. The effect of Heisenberg uncertainty principle is significant only for motion of macroscopic objects. Macroscopic means small, macroscopic objects, and is negligible for that of macro object. MAC means it has importance for micro, small, not for big. This can, by examples also, you can understand by getting the value. If just example I am giving, if uncertainty principle is applied to an object of mass, say about a milligram, 10 to the power minus 6 kg, means milligram 10 to the power minus 6 kg. It is somewhat big. Not big means in comparison when we are talking about the micro and macro. In that level, 10 to the power minus 6 is somewhat big. Then if you will calculate for this particle whose mass is 10 to the power minus 6 kg, then you will get delta V into delta X, that is, you know that uncertainty principle, delta V into delta X, that is equal to H upon 4 pi m, you know. Then here, if you will, in this formula, if you will put the value of m, because H and 4 pi value is fixed, then delta V into delta X value, that is Heisenberg this principle, if you will apply, then you will get this delta X and delta V value after putting all things value H, pi and m. You will get 10 to the power minus 28 meter square per second. See, minus 10 to the power minus 28 meter square per second. This value you are getting for this 10 to the power minus 6 kg object. This value of delta V into delta X obtained is extremely small. It is very small. Means it is just like fixed, near to accurate only. The value of delta x in delta x into delta v obtained is extremely small and is insignificant. No value, insignificant. Therefore, one may say that in dealing with milligram sized or heavier objects, the associated uncertainties are hardly of any real consequence. Now you consider other, which is really very small. Then another example, In the case of microscopic objects like an electron, micro, small, MIC, here you can see delta V into delta X obtained is much larger and much uncertainties are of real consequence. Here importance is there. In the case of micro, small, MIC, microscopic objects like an electron, on the other hand, delta V into delta X obtained is much larger and such uncertainties are of the real consequence. Means for the small it will work. For example, for an electron whose mass is 9.11 into 10 to the power minus 31 kg, minus 31, then it is very small in comparison to the above what we have considered 10 to the power minus 6 kg. That time in the case of these things, big, macro, that time 10 to the power minus 6 we have considered. Now we are considering electron weight, that is minus 31 kg, 10 to the power minus 31 kg, 9.11 into 10 to the power minus 31 kg. Then according to the Heisenberg uncertainty principle, here what you will get, delta V into delta X value. Then after putting the value of H and M, H divided by 4 pi M, then M is equal to now 10 to the power minus 31 kg. 9.11 into 10 to the power minus 31 kg. If you will put all the value, then now you will get delta V into delta X value is equal to 10 to the power minus 4 meter square per second. It therefore means that one tries to find the exact location of the electron, say to an uncertainty of only 10 to the power minus 8 meter, then the uncertainty delta V in velocity would be, see here what you have done, first you have calculated delta V into delta X value. That value is 10 to the power minus 4 meter square per second. This is the delta X into delta V value. Now you want to calculate now delta V, then you have to divide by this now 10 to the power minus 8 meter. That is actually if one tries to find the exact location means position of the electron to an uncertainty of only 10 to the power minus 8 meter. 10 to the power minus 8 meter is the uncertainty in location, means position. Then for both value delta V and delta X is equal to 10 to the power minus 4 meter square per second. But any one is given. As for example, delta X is given. Then now you can calculate the delta V, because total uncertainty is given, that is the 10 to the power minus 4 meter per second, that is the total including both, and for position only, for location or position only, it is the 10 to the power minus 8 meter. Hence, if you want to know the delta V, then just divide it, total divided by delta x. That's why value will come. You will put the value total, means 10 to the power minus 4 meter square per second divided by 10 to the power minus 8 meter. Then now we will get 10 to the power 4 meter per second. This is a very big value, which is so large that classical picture of electrons moving in Bohr's orbit, that is telling about the fixed, cannot hold good. No value for that orbit. It's therefore means that the precise statement of the position and momentum of electrons have to be replaced by the statement of probability that the electrons has at a given position and momentum. You can tell probability of an electron, what will be its position and momentum at any particular instant, at a particular time, where will be the electron, what will be its momentum, what will be its position. Only probability you can tell, because always it is moving. It is not fixed, it is not static. Always it is moving. That's why exactly you can tell probability word can be used, not the exact. Probability term is used. That is the improvement is required in Heisenberg uncertainty principle, the term introduction of term probability, because I have shown you that see, if you want to know the position, then velocity is changing fast, changing more. If you want to change, know the this momentum, means velocity, then position is changing. Hence, only probability can be possible. Probability term we can use for uncertainty, Heisenberg uncertainty principle. Now, actually numericals is there in the last. I will tell the numericals. Now, I want to tell reasons for the failure of the Bohr's model. First to understand, then numericals I will come. Reasons for the failure of Bohr model. Actually, we have discussed last class, that is the shortcomings or limitation of Bohr's model. Now here you can understand reason. What was the reason for the failure of the Bohr model? Shortcoming is different. Shortcoming and limitation, that is different. Here real reason for the failure of the Bohr's model I am going to discuss. One can now understand the reasons for the failure of the Bohr model. In Bohr model, an electron is regarded as a charged particle. In Bohr model, an electron is regarded as a charged particle moving in well-defined circular orbits about the nucleus. This is according to the Niels Bohr. The wave character of the electron is not considered in Bohr model. See, important thing, why it became failure, reason for the failure. Then main reason is that the wave character of the electron is not considered in Bohr model. Further, an orbit is a clearly defined path, and this path can completely be defined only if both the position and the velocity of the electron are known exactly at the same time. If you can say both are known, means velocity and position are clearly known, only then you can define well-defined path you can tell. But here neither they are knowing position nor the velocity of electron. Then how can well-defined? You can't tell that path is well-defined. This is the, you can say, reason for failure of the Bohr's theory, Bohr's atomic model. This is the main reason for failure. This is not possible. This is not possible according to the Heisenberg uncertainty principle. Means without, if both are not known, then this is not well-defined path. This is according to the Heisenberg uncertainty principle. Bohr's model of hydrogen atom, therefore, not only ignores dual behavior of matter, but also contradicts Heisenberg uncertainty principle. It is against the Heisenberg uncertainty principle. In view of this inherent weakness, in the Bohr's model, there was no point to extending Bohr's model to other atoms. In fact, an insight into the structure of the atom was needed, which could account for wave particles duality of matter and consistent with Heisenberg uncertainty principle. This came with the advent of quantum mechanics. These things, failure and other things, all things became clear when new theory, that is a quantum mechanics, that is called advent of quantum mechanics. When quantum mechanics came, all things became cleared, and final theory till date, that is the best suited for the atomic structure, that is the quantum mechanics. That we will discuss in the next class, but now I am going to discuss some numericals, because without numericals you can't understand 100% about the, you can say, concept. Then now first numericals I am telling you. Question I am reading. A microscope using suitable photon is employed to locate an electrons in an atom with a distance of 0.1 angstrom. What is the uncertainty involved in the measurement of its velocity? See here distance they have given. Atom within a distance of 0.1 angstrom. 1 angstrom equal to 10 to the power minus 10 meter. Okay. Then here they are asking about the uncertainty in velocity. Then here delta x is given. Delta x is given. Delta v it is asking. Then uncertainty principle, delta x into delta p means momentum. P means m into v, that that is equal to delta x into delta p is equal to h upon 4 pi. Then from this, after putting the value of delta p, that is the m into v, you can calculate directly that delta v is equal to h upon 4 pi delta x into m. From the Heisenberg uncertainty principle, this you got the relation delta v is equal to h upon 4 pi delta x into m. After putting all this value, h value is known, That is the Planck constant value, 6.626 into 10 to the power minus 13 joule second. Now divided by 4 pi, pi value 3.14, then 4 into 3.14, x value is given, that is given in angstrom, 0.1 angstrom. It means you can write that 0.1 into 10 to the power minus 10 meter, converted into the meter, and after that m of the electron m of the electron many times I told, 9.11 into 10 to the power minus 31 kg. Now after putting all value and solving, its final results comes 5.79 into 10 to the power 6 meter per second. Correct? Then see here how easily you can calculate, that is the uncertainty in velocity. If one is knowing, delta x is knowing, location you are knowing, or position you are knowing, if it is somewhat accurate, somewhat not exact, then velocity, this is changing more. Velocity is changing. Means both you can't know exactly. If one is somewhat exact, other will change. Then here velocity is changing. But what is the value of velocity? You can calculate like this way. Now, second question I am telling you, this is also very interesting. A golf ball has a mass of 40 gram and a speed of 45 meter per second. If the speed can be measured within accuracy of 2%, means delta V is 2% of 45, the speed value they have given. Again question I am reading. A golf ball has a mass of 40 gram and a speed of 45 meter per second. If the speed can be measured within accuracy of 2%, calculate the uncertainty in the position. Then here velocity they have given and uncertainty in position they are asking. Same formula. Now this time delta V they have given. Then delta V directly they have not given. 2% accuracy. 2% within accuracy of 2%. Then speed was 45 meter per second. Then 2% of this, that is the delta V. Then 45 into 2%, 2 upon 100, that is equal to 0.9 meter per second, 0.9 meter per second. Then now just same formula you can use, Heisenberg uncertainty principle. Then delta x is equal to h upon 4 pi m delta V. Then now again you put all the value of h, value of pi, m and V, all things is known. Then h is equal to 6.626 into 10 to the power minus 34 joule second divided by 4 pi means 4 into 3.14, m is equal to 40 gram, that you converted into kg by dividing it by 1000 means 10 to the power minus 3. Now kg, it became kg, and this velocity is already given 0.9 meter per second. Hence after solving, result will come 1.46 into 10 to the power minus 33 meter. This is the minus 33 is again very less. Then See, when accuracy was 2%, then now its X is somewhat, you can say, exact. But you can tell here one thing, sir. This 1.46 into 10 to the power minus 33 meter is very, very small. This is nearly 10 to the power 18 times smaller. Minus 33 is there, means you can see very, very small. Nucleus is only of 10 to the power minus 15 meter. Nucleus. And atom size is 10 to the power minus 10 meter. But here you can see 10 to the power minus 33. How small is there? Then this is nearly 10 to the power 18 times smaller than the diameter of a typical atomic nucleus. 15 and 18, 33. Then see, 10 to the power 18 times smaller than the diameter of a typical atomic nucleus. Then as mentioned before, for large particles, the uncertainty principle sets no meanings. It is meaningless. No meaningful limit to the precision of measurement. Means this value is very, very small. I told you 10 to the power 18 times smaller than the diameter of the atomic nucleus. Then already we have told for large particles the uncertainty principle sets no meaningful limits to the precision of measurements. Means for the large molecules it will not work. Okay, then today now I am stopping only here. Again we will meet in next class. Thank you.